All right, welcome to 2.4, day one. This is going to be a two-part section for us, and today we're going to talk about standard form and our essential question: how do you write and graph linear functions in standard form? Now, previously we learned about slope-intercept form, which is y equals mx plus b, and that was useful because we had our y-intercept where it was on the y-axis, and then we had our slope, and you could count from there. Now, today we're going to be working in standard form, which looks like this: ax plus by equals c. Okay, and the qualifier here is that a, b, and c all have to be real numbers, and what that means is that there's no imaginaries. For us, for this purpose, it's not a huge deal because we haven't worked with imaginaries yet this year. But just, I don't know, something to be aware of here. All right, so we talked yesterday or the day before, I don't remember, about how when it's at the y-intercept, right? It's the coordinate point would be 0, comma, whatever your y-intercept is, right? And then when it's at the x-intercept, it's whatever the x value is, comma, 0. Okay, we're going to use those because that's what standard form is good for, is finding those two intercepts. All right, so first off, we're going to start out here. We have this equation. We need to find the intercepts, and then we're going to graph it. Okay, so the first step, to find the x-intercept, we're going to plug in 0 for y, because where it crosses the x-axis, y is 0. Okay, so we're going to do 4x plus 3 times 0 equals 12. Okay, and then this becomes fairly easy because that goes away, right? 3 times 0 is 0. And we get equals 12, and so x equals 3. Okay, and so we put it in here, 3 comma 0. That's one of our intercepts, and then the other intercept. Now this time we plug in 0 for x, and so we get 4 times 0 plus 3y equals 12, and then 3y equals 12, and so y equals 4. And so then we put in 0 comma 4. And now we can graph, and it's fairly simple to graph. Okay, so our x-intercept is 3, 0, 1, 2, 3, 0 right here. Our y-intercept is 0, 4, 1, 2, 3, 4. And we have our 2 points to make our line. Whoa! Hopefully you make your line better than I did. But you get the idea. All right. Another practice problem here. Again, if we want to find the x-intercept, we plug in 0 for y, so we get 5x. And once you get going with this, you just learn that you can just leave out this part. But for our purposes, we'll plug in 0 so that we get used to it. And so we do 5x equals 20, and x equals 4. Okay, so we have x is 4, y is 0. Now for the y-intercept, same thing. 5 times 0 minus 2y equals 20. And we get negative 2y equals 20. And y is negative 10. So plug in negative 10 for y, x was 0. And now we can graph, right? So 4, 0 was our first point. 1, 2, 3, 4. And then our second point was 0, negative 10. So we're going to have to go down a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way down here at 10. Okay, and then I'll try to make my line a little bit better this time. I'm using my mouse. It's not the easiest thing to do. Okay, but you get the idea. Now, we have an equation of a line, and it's in y equals mx plus b, right? And we need to get it into standard form. And it says use integer coefficients. That means whole numbers, no decimals. Okay, no decimals, no fractions. Okay, so the first thing, we kind of undo what we did when we were talking about y equals mx plus b. When we talked about y equals mx plus b, we solved for y. Well, now we're going to try to get it to look like, the ax plus by. So we want our x's and y's on the same side. and then we're going to be just left with a constant on the right side. All right, so let's get going here. Our first step, we're going to move the 2/5 x over. And how do we do that? Well, we're going to subtract it. So minus 2/5 x from both sides. Okay, and so we're left with negative 2/5 x plus y equals, and all we have left over here is negative 3. Okay, now it's starting to take shape, right? Oops, it's starting to take shape. We have our ax plus b, this would be a 1, y equals c. But it said we need whole numbers, right? And so how do we get rid of this fraction? All we're going to do is we're going to multiply by 5. Now when we multiply by 5, we need to multiply everything by 5. Okay, this is important. Please do not miss out on multiplying this piece by 5. You need to multiply the y piece by 5. Okay, so here it cancels out and we're left with negative 2x. We have our 5 plus 5y equals negative 15. Now we have it with whole numbers in standard form, and there's our answer. All right, last thing here. Regarding slope, when we have parallel lines, the slopes are the same. Parallel lines have the same slope. They're increasing at the same rate. Okay? And then perpendicular lines, the slopes are opposite reciprocal. Opposite reciprocal. Okay, what that means, opposite, means that you switch your sign. Okay, so if it's positive, then it becomes negative. If it's negative, then it becomes positive. Reciprocal means that if you have your fraction, you're going to flip your fraction. Okay, so for example, if we have a slope of 1/3, the opposite reciprocal of that, we flip our fraction, which would make it 3, and we have to do the opposite, so we have to change the sign. Would be negative 3. Okay, another example of negative 7/2 would convert into positive 2/7. Okay, so let's keep that in mind. Perpendicular lines, opposite reciprocal slope. Parallel lines have the same slope. Okay, so we need to, now we're going to be back in slope-intercept form just briefly when we're talking about this. Okay, for a line parallel to here, it needs to go through 0.01. So how are we going to do that? Well, we know that parallel has the same slope, right? So y equals 5x. Now, it's a different line. So it's going to have a different y-intercept. It's not going to go through -4. It'll be totally different. Okay? And so what we need to do in order to find b, because it goes through a whole new y-intercept, what we're going to do is we're going to plug in this point for x and for y. Okay, so it'll be, we plug in 1 for y, we plug in 0 for x, now we need to solve for b. And this one's really easy because that goes away and we're left with b equals 1. Now the last step, we need to plug it back into our original equation. We end up with y equals 5x plus 1. And that's our new equation. Parallel to this line, these are parallel lines, but this one goes through -4 and this one goes through 1. They still have the same slope though. Okay, for this one, now we have a line perpendicular to this line, and we know that it has a y-intercept of 3, which means that it goes through the coordinate point 0, -3, right? Because it's a y-intercept. Okay, so first thing, we need to get this in y equals mx plus b form, and so we're going to divide everything by 2 to get y by itself. We end up with y equals 2x minus 3. Okay, this was our original line. Okay, now we want to find the one perpendicular. I'll do that in red maybe. Okay, so we know, first let's deal with the slope. So the perpendicular slope is opposite reciprocal, and so our new slope would be negative 1/2, right? We change the sign and we flip the fraction. X plus b. Now we don't, on the surface, we don't know what b is, but then we come to realize, well, hey there, it tells us that our y-intercept is 3, or negative 3. That's handy. Otherwise, we would have to plug in this point, which would be fine. We just plug in 0 and negative 3, and it's going to get us negative 3. So our final answer, y equals negative 1/2 x plus, minus 3. Oops. Negative 1/2 x minus 3. Okay. If it didn't give you the y-intercept, if it just gave you a point, so let's say it gave you the point 5, 5, 7 or whatever, then you'd have to plug in 7 for y, 5 for x, solve for b, and then you plug b back into your equation to get your final answer. All right, that is section 4, part 1. We'll be back tomorrow to deal with part 2.